Everybody working? Just a reminder, volume is how many cubes fill a shape, how many cubic units fill a shape. And later on, we're going to get to a point where we have a formula. So I want you to be thinking throughout this lesson what the formula for volume might be. We're going to start with this right rectangular prism. Again, all the sides are rectangles for it to be a right rectangular prism. And we're going to label the dimensions. So we're going to label the length of 1, 2, 3 units. And I just write 3 units because if I wrote units squared, it would be area. If I wrote units cubed, it would be volume. But units just tells me a length measurement. The width is 2 units, and the height is 1, 2, 3, 4 units. Okay, using this information, let's go ahead and find the volume by again using layers like we did the other day, and using that to help us eventually get to using just multiplication. So now that we've labeled the dimensions, let's go ahead and find the volume. Well, here I see that they've partitioned or split up the shape horizontally like cake layers. And in each layer, I have 1, 2, 3, 4, 5, 6 cubes. 6 cubes in each layer, and there are 1, 2, 3, 4 layers. Well, 6 plus 6 plus 6 plus 6, or 6 times 4, gives me a volume of 24 units cubed, or cubic units. Same thing there. Let's look at this one that's split up like bread slices, partitioned like bread slices. And so we're looking at these layers here. How many cubes are in this layer? Well, in this layer, we have 1, 2, 3, 4, 5, 6, 7, 8 cubes in each layer. 8 cubes in each layer, and we have 1, 2, 3 layers. Again, 8 plus 8 plus 8, or 8 times 3, gives us those 24 units cubed, or cubic units. Well, when we're counting this to find how many cubes are in each layer, really we're just looking at one of the faces of the right rectangular prism. Well, let's look at a simple 1 cubic unit right rectangular prism. And I see that one of the faces is here. And I can see that that face is 1 square. I see that that face is 1 square. But I know that this is 1 cube in that layer. So it looks to me like the number of squares on one of the faces is the same as the number of cubes in a layer. Let's go to our actual right rectangular prism that we were just working on. And we were looking at these layers here. Well, to figure out how many are in this layer, I'm going to look at this face. I'm going to go ahead and trace that face onto my grid paper. And that face is 1, 2, 3, 4, 5, 6 squares. And we were saying earlier that there were 6 cubes in that layer. Well, now I'm curious. Instead of us always just counting cubes, because one day we won't have the cubes to count, we won't be able to see them, how can I come up with that number of 6 cubes in a layer by using these dimensions that we have here? Where do you see numbers that can get you to 6? Well, I'm looking here and I see that this is an area of 6. Well, how do we find area? We multiply length times width, correct? If I multiply 3 times 2, I get 6. Well, that 3 and 2 are right here. So I can go ahead and write 3 times 2, and that's how we could come up with the number of cubes in one of those layers. Let's look at the second one. Here they split it up vertically like bread slices. So if I wanted to know how many cubes were in each of these layers, I would probably be looking at this face here. Or I'm sorry, for our drawing, we would look at this face here. So I'm going to go ahead and trace that face. Oops. And when I do that, I'm seeing that I have 1, 2, 3, 4, 5, 6, 7, 8 squares on this side of my prism. Well, that's how many we said were in each layer, how many cubes were in each layer. Well, the area of that side of that face is an area of 8 square units. Well, that area was the same as how many were in that layer. So I'm going to come back to our chart and I'm going to write, well, how did we get 8? I have these dimensions here. How can I get 8? Well, if I have an area of 8, I can do 4 times 2. Just like we have these dimensions here, 4 times 2. I think we're rocking it. So let's look at the last way to break it up. The last way to break it up, which is to break it up into these layers, these 2 layers here. And we want to know how many are in each layer. So I'm going to count the squares on this face. So let's go ahead and trace that so it's easy for us to see. Oops. And on this face, okay, I turned it, so sorry. Oops. On this face, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have an area of 12 square units. Well, how can I use that area and look at the dimensions of my original shape, my original figure? Well, area, here I'm doing 4 times 3. 4 times 3. So how many cubes are in each of these layers? Well, we can count, and we've already done our drawing. We know that there are 12 cubes in each of those layers, which we found to be 4 times 3. And there were 2 of those layers giving us a volume of 24 units cubed. So that whole time that we've been counting cubes on the side of a shape, we've really been figuring out the area. But now that we have dimensions, we might not need to count every time. So let's assume we have a different prism. Let's assume we have a different prism, and that prism has a volume, once again, of 24 units cubed. But this time, I'm only going to tell you that that prism has 4 cubic units in the bottom layer. How many layers must this prism have if it has a bottom layer of 4 cubic units but still has a volume of 24 cubic units? Maybe some of you figured it out. It would have a volume of 24 cubic units, giving us 6 layers. Okay, if we had a right rectangular prism, excuse my drawing, not perfect. And this time, we knew that it had 8 layers, 1, 2, 3, 4, 5, 6, 7, 8 layers. And this time we wanted to know how many cubes are in each layer. Well, let's see, it still has a volume of 24 units cubed. How many cubes are in each layer? If I have 8 layers, my answer would be 3 cubes. Let's see if some of you are catching on to the math that we have here. Okay, now I told you at the beginning of our lesson, our goal is to find the formula for volume. The volume formula. So, if I'm finding the volume formula, let's look at something we've worked at before. Okay? We know that we're going to use the dimensions in our formula. How can I use these dimensions to find the volume of a right rectangular prism? Here the volume was 24 cubic units. How can I use these numbers, the dimensions of the length, width, and height, to find this volume? Well, let's see if what you've come up with matches our volume formula. Volume equals length times width times height. So for this problem, we have 3 times 2, which is 6, and 6 times 4, which is 24. We get the volume that way. Now for volume, we actually have 2 formulas. They will give us the same volume, but we like to pick the one that uses the information that's given to us. Our second formula has to deal with what we've been talking about a lot today already, which is area. If you noticed, we multiplied here length times width, and we got those 6 cubes. Well, those 6 cubes then we multiplied by how many layers? Well, guess what? Layers are the same thing as height. So instead of me saying length times width, we could say the area of the base times the height. Because we know from what we've done earlier today that when I find length times width, which is part of our formula, I actually come up with an area. So let's look at this first problem of ours. And we're going to determine which of these formulas we would like to use. I recommend always writing down the formula so that way it's right in front of you and all you have to do is plug in information that you have. Well, I happen to know that the area of this base is 4, and we're going to call it centimeters squared. Squared because it's area, and centimeters because that's what our problem is calling for. So for this, I'm given the area. So I'm going to use volume equals area of base times height. Area of base times height. And our height, or our layers in this situation, is 5 centimeters. So now we just plug in the information into the formula. The area of the base, oh, that's 4. The height, well, that one's 5. So our volume would be 4 times 5, which is 20. Don't forget, we always have to label our volume, so I would say 20 centimeters cubed or 20 cubic centimeters. Now, had I wanted to do the other formula, I could figure it out here because everything's labeled. So here I see that I have a length of 2, a width of 2, and I could use volume equals length times width times height and plug in 2 times 2 times 5. 2 times 2 is 4. 4 times 5 is, again, 20. So either formula would work for this particular problem, but you always want to pick the formula that works with the information that they give you. Okay, let's look at this next problem. It says, write an equation to find the volume of the given figure, then write its volume. Well, here we have a length, a width, and a height, but the height is a variable. We don't know the value of the height. We don't know how many layers are there. So it's very simple, but we're going to use our formula, volume equals length times width times height, and plug in the information that we know. Well, I'm going to plug in my length of 3. Remember, length is normally the longest side unless they tell you the width is the longest side for some reason. So we have a length of 3, a width of 2, and a height of k. Well, we're going to do the parts of it that we can do. I can do 3 times 2. I know that's 6. So now I'm left with 6 times k. And to be honest with you, that's pretty much where we can stop. We can say volume equals 6 times k. This is centimeters cubed. We could say volume equals 6 parentheses k, because if you remember, if a number is touching the parentheses, that means multiplication. Or, because it's a variable, it has a very special rule, we can write the 6 right next to the variable, and that means multiplication as well. So we're done. All we had to do was find that unknown. If you would like to have some help on the problem set, I'm going to ask you to stay on the video and you can check your work with what I do. Otherwise, volume equals length times width times height, or area of the base times the height. And we don't need to count cubes anymore.